Hello everyone. Today's topic atoms and molecules, atomicity and writing the formula of compounds. And this topic is meant for students of grades 7th to 9th. Please subscribe, share and like my videos. Elements have atoms and molecules. The number of atoms present in a molecule of an element is referred as atomicity. Some elements have one atom, some elements have molecules with two atoms, three atoms, and so on. So, metals such as sodium, potassium, magnesium, calcium, barium, etc., they have individual atoms. Therefore, their atomicity is 1. Thus, their atomicity is 1 and they are referred as monoatomic. Gases like hydrogen, oxygen, nitrogen, fluorine, chlorine, of course, bromine is liquid, iodine in solid state. They have molecules with two atoms. Thus, their atomicity is 2. So, their molecules are H2, O2, N2, F2, Cl2, Br2, I2. Thus, their atomicity is 2. Inert gases are helium, neon, argon, krypton, xenon and radon. Inert gases do not react with other elements. Therefore, they do not react with other elements and they do not react with them also. That's why they are available as individual atoms. Thus, their atomicity is 1. Therefore, they are referred as monoatomic. Ozone. You know that ozone layer, it is the uppermost layer of atmosphere which protects the earth and us from the ultraviolet radiation coming from the sun. So, ozone molecule is O3, therefore its atomicity is 3. Phosphorus molecule is P4, therefore its atomicity is 4. We have one more also, sulfur. Sulfur has S8 molecules, therefore atomicity of sulfur is 8. Ion. Ion means an atom or group of atoms having certain charge is known as ion. An ion is also referred as radical. So the charge may be either positive or negative. So positively charged ion is referred as cation or positive radical. Similarly, negatively charged ion is referred as anion or negative radical. Magnitude of charge. Magnitude of charge means amount of charge. Amount of charge, which means it may have 1 unit of charge or 2 units of charge or any number of charge. The magnitude of charge is mentioned on the superscript of the symbol or formula of an ion as Mg2 plus. That means magnesium ion has 2 units of positive charge. Ammonium ion NH4. Ammonium ion has 1 unit of charge. Oxide ion. Oxide ion has 2 units of negative charge. Nitrate ion. Nitrate ion has 1 unit of negative charge. Now let us learn certain positive radicals. Positive radical means they have positive charge. The amount of charge may vary from one radical to another radical. So this is radical and symbol. Sodium radical Na plus, potassium K plus, that means they have the amount of charge as 1 unit. Silver Ag plus with 1 unit of charge. Ammonium, it is a polyatomic ion. Polyatomic ion means it has more than one type of atoms. That is 1 nitrogen atom and 4 hydrogen atoms with a positive charge 1 unit. Cuprous. Cuprous is also referred as copper 1. So this 1 Roman 1 indicates 1 unit of charge on copper ion. Cu plus. Mercurous or mercury 1. Mercurous ion has 1 unit of positive charge Hg plus. Cesium ion Cs plus. All these radicals are referred as unipositive radicals. Uni means one. Unipositive radicals. They have 1 unit of positive charge. Now let us discuss more positive radicals. Radical and symbol. Now this is magnesium Mg2 plus. It is a dipositive radical. Now all these radicals, they have 2 units of positive charge. Dipositive radicals. Calcium Ca2 plus with 2 units of positive charge. Barium Ba2 plus. Nickel Ni2 plus. Ferrous or iron 2 Fe2 plus. Here ferrous has 2 units of positive charge. So ferrous iron is also referred as iron with Roman 2 in bracket. Cupric or copper 2. The charge on copper ion, cupric ion is 2 units of positive charge, therefore it is copper 2. Plumbus or lead 2, Pb2 plus. Mercuric or mercury 2, Hg2 plus. Stannous or tin 2, Sn2 plus. Here you might have noticed that, see here, previously we discussed the cuprous ion. Cuprous ion has 1 unit of positive charge. Now cupric ion has 2 units of positive charge. That is, if an element is available in 2 types of ions, the ion with less positive charge is referred as us. The name ends with OUS, us. If the charge is more, the name ends with IC, ic. So cuprous, cupric. Cobalt 2 plus. More radicals. Aluminium. So all these radicals, magnesium, calcium, etc., all these referred as dipositive ions. Now aluminium Al3 plus, it is a tripositive ion. Plumbic or lead 4, Pb4 plus. Say here you can observe the difference. Plumbus with less amount of positive charge ends with OES. Plumbic more amount of positive charge ends with IC. Plumbic or lead 4, Pb4 plus. Stannic or tin 4, Sn4 plus. Till now we discussed about the positive radicals. Now let us see negative radicals. So fluoride F minus. So in case of negative radicals, the name of the ion ends with IDE if the charge is 1 unit of negative charge. Chloride Cl minus. Bromide Br minus, iodide I minus. So all these radicals have only one element. Therefore, if the negative radical has only one element, the name ends with IDE, suffix IDE. This is chlorate. See the difference, chloride and chlorate. See, if the radical has element along with oxygen, so the name ends with ATE or ITE. So chlorate ClO3 minus. So here this is a polyatomic anion with 1 chlorine atom and 3 oxygen atoms with 1 unit of negative charge. Bromate BrO3 minus, iodate IO3 minus, nitrate NO3 minus, nitrite NO2 minus. Here find the difference. Nitrate and nitrite. Both the ions have the same type of atoms, nitrogen atom and oxygen atoms. In nitrate, the number of oxygen atoms is 3. In nitrite, number of oxygen atoms is 2. Thus, in such cases, if the quantity of oxygen or number of oxygen atoms is more, the name of the radical ends with the suffix ATE. Here, number of oxygen atoms is less, therefore the name ends with ITE. So, nitrate and nitrite. Hydroxide, OH minus. So, this is an exceptional case. Though it has 2 elements, oxygen and hydrogen with 1 unit of negative charge. So, the name ends with IDE. More radicals. Bisulfate or hydrogen sulfate. HSO4 minus. So it is a polyatomic anion with 6 atoms, 1 hydrogen atom, 1 sulfur atom, 4 oxygen atoms. Bisulfite or hydrogen sulfite HSO3, bicarbonate or hydrogen carbonate HCO3 minus, that is 1 unit of negative charge. Permanganate MnO4, 1 manganese atom but 4 oxygen atoms with 1 unit of negative charge. Dihydrogen phosphate HTPO4 minus, 2 hydrogen atoms, 1 phosphorus atom, 4 oxygen atoms with 1 unit of negative charge. And all these radicals are referred as uni-negative radicals. See here, all these radicals, they carry only 1 unit of negative charge. Therefore, they are referred as uni-negative radicals. Now, let us see more negative radicals. Oxide. Oxide has 2 units of negative charge, O2 minus. So, the charge is represented on superscript followed by number, that is magnitude of charge with a negative sign. So 2 minus indicates 2 units of negative charge. Sulfide, S2 minus. Sulfate, it is a polyatomic anion with 1 sulfur atom and 4 oxygen atoms with 2 units of negative charge. Carbonate, CO3 2 minus, 2 units of negative charge. Sulfite, SO3 2 minus. See here, observe these two radicals, sulfate and sulfide. More quantity of oxygen ends with ATE, less quantity of oxygen ends with ITE. Permanganate, this is not permanganate, manganate. Only MANGANATE, manganate, MnO4 2 minus. Dichromate, Cr2O7 2 minus. Hydrogen phosphate, HPO4 2 minus. Silicate, SiO3 2 minus. Say all these are di-negative radicals. That is, they have 2 units of negative charge. Let us see more negative radicals. Nitride, nitride N3 minus. Nitride is a tri-negative radical. It has 3 units of negative charge. Phosphide, P3 minus. Phosphate, PO4 3 minus. Phosphate radical has 1 phosphorus atom and 4 oxygen atoms with 3 units of negative charge. Now radicals having the same atoms but different in quantity of oxygen or number of oxygen atoms has a little difference in their names. So this we discussed already in the previous slides. So here the name of the radical has less number of oxygen atoms ends with ITE. The one with more number of oxygen atoms or more quantity of oxygen ends with ATE. And of course, let us have an example. Nitrite, nitrate. Nitrate NO2 minus, nitrate radical is NO3 minus. So here less quantity of oxygen, here more quantity of oxygen. Therefore, the radical with less quantity of oxygen is referred as ITE and radical with more number of oxygen referred as ATE. So let us have one more example. Sulfide, sulfate. SO3 2 minus, SO4 2 minus. Here less number of oxygen atoms, more number of oxygen atoms. Now let us learn how to write the formula of compounds. Dear all, this is very, very important to learn chemistry from fundamentals. So this is a fundamental basics and we have to learn to write the formulae of compounds using the knowledge of radicals, that is positive radical and negative radical. And of course this method is referred as crisscross method. In general, a salt has 2 radicals. Salt has 2 radicals or the name of the salt has 2 parts. The first part is positive radical and the second part is negative radical. Now let us learn how to write these formulae of compounds by taking different examples. Sodium chloride. See here, sodium, the first part is positive radical, second part is negative radical. So sodium is positive radical, chloride is negative radical. The name should not be written as a chloride sodium. So this is the order which we have to follow in writing the formulae of compounds. What is the radical of sodium? Na plus, chloride radical Cl minus. Observe here, sodium has 1 unit of positive charge, chloride has 1 unit of negative charge. That means numerically the charges are same, Numerically, the charges are 1 unit each. In such cases, see, whenever you write the formula, the magnitude of the charge of a positive radical should be given to negative radical and vice versa. That is, magnitude of the charge of negative radical should be given to positive radical. So here, this 1 unit should be written here as a subscript, and Na plus it has 1 unit of charge and Cl1. Please keep this point in mind. While exchanging the charges, you have to take only magnitude but not the type of charge, whether it is positive or negative. See here, since the charges are same, simply we write NaCl. So sodium chloride formula is NaCl. Now let us see another example, silver nitrate. What is the radical for silver? Ag plus. Nitrate NO3 minus. Say here both the radicals are monoatomic. In this case, nitrate ion is polyatomic anion. And here also observe that the magnitude of charges are same, plus 1 unit, minus 1 unit. In such case, what we have to do? Simply we have to write the charges as subscripts to the radicals. So Ag1, NO3, 1. See here it is mentioned in bracket. If you do not keep this bracket, the number is understood as 31. That is, this is understood as 1 nitrogen atom and 31 oxygen atoms, which is not correct. That's why we have to keep the bracket. Anyhow, this because it is 1 this 1 can be neglected while writing the formula. So the formula of silver nitrate is AgNO3. Now let us have one more example, calcium sulfate. What is the radical of calcium? Ca2 plus. Sulfate radical SO4 2 minus. So here also charges are same, that is 2 units of positive charge, 2 units of negative charge. In these two cases the charges are same, that is magnitude is 1 1, whereas here the charges are same but the magnitude is 2 2. In such cases what we have to do? We have to exchange the magnitude of charges. So Ca, this 2 will come here, this 2 will come here. So Ca2 SO4 in bracket 2. So why should we keep the bracket? In order to prevent the confusion that whether it is 4 oxygen atoms or 42 oxygen atoms. Okay? Right. Therefore, since the charges are same, simply you neglect these magnitudes of charges. That is, the formula of the calcium sulfate is CaSO4. Now let us see more formulae. Sodium sulfate. So what is the radical of sodium? Na plus. Radical of sulfate 2 minus. See, observe the difference. In the previous three cases, the magnitudes of the charges are same. But here the magnitude of charges are not same. Sodium radical has 1 unit of positive charge. Sulfate radical has 2 units of negative charge. So here what we have to do? The magnitude of charges should be exchanged. So sodium has this 2 and sulfate has, sodium has 1 unit of positive charge, therefore this 1 should come here. If 1 is there, it is not necessary to write. Therefore the formula of sodium sulfate is Na2SO4. Okay. Now let us see one more example. Potassium carbonate. The radical of potassium is K plus, carbonate CO3 2 minus. This formula is just like above one. So charges are not same, magnitudes of charges are not same, therefore charges should be exchanged. So magnitude of charge of carbonate should come to potassium and magnitude of charge of potassium should come to carbonate. So if this 2 is written here, 1 it is not necessary to write. Therefore the formula of potassium carbonate is K2CO3. Now let us see one more example. Calcium nitrate. Radical of calcium is Ca2 plus and nitrate is NO3 minus. Here 2 units of positive charge, here 1 unit of negative charge. Therefore the magnitudes of charges should be exchanged. So this 1 comes to calcium and this 2 comes to nitrate. Here bracket should be kept. If bracket is not kept, it is understood as 1 nitrogen atom and 32 oxygen atoms, which is not correct. There, the nitrate radical is NO3. So as we kept 2 here, it is understood that calcium nitrate molecule has 2 units of nitrate. Therefore, this 1 is neglected. Finally, the formula of calcium nitrate is CaNO3 2 taken twice. So it is also read as taken twice. CaNO3 taken twice. Observe the difference between this substance and this substance. See, in this substance, positive radical has 1 unit and negative radical has 2 units of charge. In this case, positive radical has 2 units of charge and negative radical has 1 unit of charge. So, whatever be the charges, the magnitudes of charges should be exchanged while writing the formula of the substance. This is a very simple thing. If you remember this, it is very easy to write the formula of the substances. Now let us see one more example. Magnesium chloride. Magnesium radical is Mg2 plus, chloride Cl minus. So here 2 units of positive charge, here 2 units of negative charge. So if the magnitudes are exchanged, so this is Mg1 Cl2 Cl2. Observe here bracket was not kept, whereas bracket was kept here. Why it is so? It has chloride radical has only one atom, that is atom of one type of element, whereas here nitrate radical has atoms of 2 different elements. Since 2 different elements are there, bracket should be kept. Here bracket is not necessary to keep. Therefore, finally the magnesium chloride formula is MgCl2. This one is not necessary to keep. Now another example, ammonium sulfate. Ammonium, it is the only polyatomic anion, NH4 plus. 1 nitrogen atom and 4 hydrogen atoms with 1 unit of positive charge. Sulfate radical SO4 2 minus. Charges, magnitudes of charges should be exchanged with one another. Therefore, this 2 should come here, this 1 should come here. 1 is not necessary to write. Since it is a polyatomic cation, so this 2 should be kept while taking the bracket. Therefore, NH4 twice SO4. This is read as NH4 twice SO4. NH4 to SO4. Ammonium sulfate. Another substance, ammonium nitrate. Say here, charges are same. NH4 plus 1 unit of charge and NO3 minus 1 unit of negative charge. So since charges are same, simply you bring these two close to each other. Therefore, that becomes the formula of the substance. I think you have understood this, how to write the formula of substances. In all these formulae, while writing, we exchange the magnitudes of charges. Why should we exchange the magnitudes of charges? See here, let us take an example, calcium nitrate. In calcium nitrate, the charge on calcium radical is 2 units of positive charge and charge on nitrate radical is 1 unit of negative charge. So here charges are not same. In order to equalize the charges so that ultimately the substance finally doesn't have any charge. So in order to equalize the charges, magnitudes of charges should be exchanged. So in calcium nitrate, calcium has 2 units of positive charge, 1 ion into 2 units plus here 2 ions, 2 nitrate ions into 1 unit of negative charge. Totally the charge is 0. Therefore, the substance is neutral. In ammonium sulfate also, ammonium ion has 1 unit of positive charge, sulfate radical has 2 units of negative charge. So if we exchange the magnitudes, the formula becomes NH4 twice SO4. So the charges are here 2 ammonium ions, 2 into plus 1 and 1 sulfate ion, 1 into charge on sulfate ion is minus 2. Therefore, totally the charge is 0. Lead nitrate, potassium bicarbonate, sodium nitrate, silver sulfate, nickel chloride, barium bicarbonate, cobalt chloride, calcium bisulfate, potassium chlorate, sodium iodate, potassium iodide, lead 2 iodide, potassium phosphate, sodium silicate, magnesium carbonate, silver nitrate, ferrous sulfate, potassium carbonate, sodium bromate. So write the formula of these substances. Have a good practice. Please keep the point in mind for writing these formula of substances as assignment or in examination. You must remember the formulae of positive radicals and negative radicals. If you practice it for once in a day for 4 or 5 days, you will remember all the radicals. And in the next module, we discuss about mole concept and finding the molar mass of elements and molecules. Thank you.